Sending out the data. Okay, hello everyone. Welcome to tonight's live stream, and I've got Kyle with me tonight. So
hello everyone.
And for those who don't know me, my name's Matt. I hope you're all well there. Now we've got Tomo in the chat. Can't wait. Give us a shout. Hey Tomo, how you going? And okay, so we're going to start off tonight with the butterfly cluster. So this, you might have had a quick look at this, super zoomed in when a couple of weeks ago with Roger, but because we're not using his telescope and we're using the big 14-inch telescope tonight here at the observatory, we'll be looking at it first off, and then we'll try and do the Triford Nebula, and then we'll try and get the Triangulum Galaxy a little bit towards the end. So it's going to be a little bit shortened one. I got back from Calgary yesterday late, so it was a really good trip, and it was quite amazing seeing the skywalk all lit up, and for the people that were having dinner there. So highly recommend it. It was done by Best for Travel in Hillary, so we're looking to maybe go back up in December as well. So it's very lovely up there. It was a nice holiday as well. Okay, so if you guys don't know what this is we've been doing this since the start of the coronavirus, once we had to shut down. So we do this fortnightly at the moment, with now that we can do our tours again on Wednesdays, and we're going to be having a look at some cool stuff in the night sky. So if you want to ask any questions, we've got the Discord channel here, and if you check the links in the description, or you can go to the YouTube page, there's in the description there's the link so you can join our Discord channel and ask us questions as well. And please get involved. This is where we want you guys to be just as involved as we are here, because it's good to get some different questions every now about, and also there's some stuff that we might not have said that you might be interested in as well. And while you're at it, we do have the Discord channel here. If you want to sign up and help us do these live streams, you'll get some cool merch as well. And so first of all, we're going to take our image of the butterfly cluster. It's a little bit hazy in the western sky, so it probably won't be absolutely perfect, but still, the butterfly cluster is a really nice open star cluster to show on a night. So this is for people who haven't seen this before. This we use backyard Nikon. We're using a Nikon D810A camera connected to my laptop, and I run backyard Nikon on to control the camera. And the telescope is a Meade 14 LX200 ACF, and so it's a really nice telescope. Unfortunately, the fork mount's a little crap, but you can't get everything in this world, can you, Kyle?
No. For those of you that didn't understand all the letters that Matt rattled off, the Meade telescope, the Meade 14, is 14 inches wide. That's how big the primary mirror is. So that's quite a bit of light gathering area.
Yep.
And it's actually computerized. So that's why he's referring to when he talks about the fork mount. It's got two motors,
yep,
which drive it. Which drive the fork mount and actually point it at different targets. So it's handy in that it's computerized. It's quite literally point and click, but the actual mounting hardware and the motors aren't the greatest, unfortunately.
Yes.
So the image wobbles a bit.
And yep, it is. It can be temperamental also with being with computers and everything like that. So it's a reflecting telescope. So it's using two mirrors with the primary mirror concaved, sending that light through, or the light coming through the telescope, hitting the primary mirror. That primary mirror sending that light to the secondary mirror back up the top. And then the secondary mirror sends that light through a hole in the primary mirror into the camera, and so that's how the telescope works. And it's got it's a really good telescope, even though we bag it a little bit.
It's better than what we had 10, 15 years ago.
Yes.
And, in terms of amateur astronomy, the technology available at actually a pretty reasonable price to the average consumer has really come a long way.
Yeah, Kyle, I think what I was trying to do there was I realised I was digging myself into a hole there, that it could just decide, well, you're talking smack about me, I might as well just misbehave on you tonight. So
Oh dear.
But we've got a couple more. Hey Mels, how you going? And also Kill Anthony, how are you going as well? And no problem. Glad we're able to do it tonight. Okay, so let's take our first image. So we're going to go 10 seconds, don't you think we should do?
Yeah, sounds good.
Yep. And we'll do ISO 3200. And let's see what we get. Actually, that's what we should. I should get the old Jeopardy music as well, and
get your little soundboard up there.
Yeah. If we really get this stuff going, so here we go. It's now, so it's taking the dark frame now. So the butterfly cluster is an open star cluster, and Kyle, what is an open star cluster?
So, it's hard to explain without going through all the phases of stellar evolution, but think about an open star cluster as a family of stars. They all form from the same big gas cloud floating in space, all around the same time in stellar evolution scales. So they're all gravitationally bound, and they're called an open cluster because they're not all bunched up together. They still orbit around the same point in space. They're all gravitationally attracted to one another. But there's a bit of space in between them. There's usually a couple of light years in between the stars in an open cluster, but they're all kind of the same family of stars.
Yep. So when you get a mummy star and a daddy star together, and that's a nebula. But this is so we're talking about stars that have just formed, and they're anywhere between say toddler to high school stars. So that's what we're really saying, aren't we?
Yeah.
Yep.
So most of the open clusters that we know of are actually quite young in stellar terms. So if you take our home star, the Sun, for example, it's about 5 billion years old. Most of the open clusters that are quite bright and close to us are a few million to a few 100 million years old.
Yeah.
They're actually quite young in terms of stellar evolution.
Yeah, so these ones are supposed 94 estimated age is supposed to be 94.2 million years old. So they get then they're probably primary school to high school stars. So in a couple of 100 million years, they'll go off in their own directions as well. Oh, we have a couple more people saying what's up. Hey, Floating Leaf 4220, and hello, Antonio. Thanks very much for joining us. Okay, and so this is actually 6 light years across as well. So it's quite a smallish little open star cluster, and you can find this actually in near the stinger of Scorpio in the west at the moment as well. Oh, and Rhodas, are the Pleiades an open star cluster? Yes, they are, and they're actually very, very close. They're about 440 light years. I think it was the Gaia Space Telescope has determined they are. And so they're actually a really perfect example of them. They're actually even too big to actually look through this telescope with. They're best to look through them with the binoculars. And we will be able to start showing them later on in the season as it comes up a little bit. Yes, we actually just had a very bright pass of the International Space Station tonight at about, I think it was about 17 past 9. Linda Bell was mentioning just beforehand that. So it was magnitude minus 3.7 tonight. So that was
quite bright.
Yes, yeah. It doesn't get. I think the brightest I've ever seen it is magnitude minus 3.9, and that it was very bright there, very, very bright. Hello, Ida. How you going? Hello, Mia Silla, and also Team Coxie. Hello, Josephine. thanks for joining us.
Hello, everyone.
Yeah, and this it's got a nice little orange star, which you can see just in the bottom right there, and you can see just there. That's a nice little red giant. You can actually see that this is actually, it does look like a butterfly. You've got the head, the body, and the wings as well. So it is something that you that there are things that have been named and they actually look like what they're supposed to as well.
Yeah, a lot of times when I'm on the telescopes up there, you get these questions. Oh, I can't see that, the shape that, these particular stars make. It's like, yeah, I can't either sometimes.
Yeah, and this was actually discovered by Giovanni Horridini, Battista Horridini, and in 1654. So we have known about it for a long time now. It can be quite. You can just pick it up with the naked eye next to the more visible Ptolemy's cluster as well. The estimates of the distance have varied over the year. It's been found to be about 1,500, nearly 1,600 light years away from us. So give or take about 12 light years. And so it's got about 120 stars, and you can get some really bright ones, but you can get some very dark ones, which are magnitude 15 as well. So you do need to really take long exposures to see them as well.
Yeah, so in this picture here, we're only really seeing the brightest stars in that cluster. There's a lot more in the background, but we need to actually expose the camera for a lot longer to bring them out.
Yeah, so because it's low in the west, this is kind of probably going to be the farewell for this year, for the swan song for this cluster. It's funny just thinking at the beginning of the year, just thinking, oh, I can't wait till we get Jupiter and we will get Saturn. Then you look at it and you realize how close to the west we are to having to give up on it. So, yeah. And they do have some. This cluster does have quite a few variable stars as well. So if we were to take photos of these over a long period, you would actually get to. And we played it through like a video of each of those. So you would eventually see some of the changing in the brightness as well from these stars.
Well, we've got a question from Floating Leaf 420. What's the best time to view the stars at night? So the short answer is any time after astrodark.
Yeah. So it's always best to see stuff when it's directly above you. That's the best way to see stuff. If it's low on the horizon, it's going to have to go through a lot more atmosphere, and so that means you get a lot of lensing. So you can kind of see that it's not absolutely perfect with the focus today with this cluster. It's there was a little. Yeah, the atmosphere wasn't behaving itself tonight. And we have Night Star saying, hello. Hello, how are you going, Night Star? All right, so what we'll do is I'll try and get our next... we'll go to the Triford Nebula as well. So what I'll do is, while I'm at it, while I'm getting it ready, what I'll do is, you've taken a lovely picture of the Triford Nebula. Let me just get it up here for you.
Oh yes, the one I sent through earlier today.
Yes. So
here's one we prepared earlier.
Yes, and so you can be thoroughly disappointed when you see my attempt. Okay, all right, here we go, and I'll get the Trifid up on the telescope.
All right.
Okay.
Yeah, Trifid Nebula is a really fun object to actually look at and to image, because you get two very different beasts when you between imaging and actually seeing it visually through a telescope. Because the Mark I eyeball is actually a pretty garbage light gathering device. Unfortunately, it's not the greatest at resolving fine details in low light conditions, where humans are daylight predators after all. But yeah, as you can see, here it is, and the pink is glowing hydrogen, and the blue around that is actually reflected starlight off interstellar dust. So generally, like when you see the color blue in space, it's from blue stars. If you see it like quite diffuse around, it's either a hydrogen beta emission line, which is actually quite dim, or it's more generally reflected starlight.
Okay.
Yeah, it's one of my favorite objects to image, because you can either take this wide view, which I've taken here. So this was done with a 10-inch Newtonian telescope and many hours of subframes. So I think this in total is about 5 hours worth of exposures, all stacked on top of each other, and then just a few touch-ups here and there, just to reduce some of the noise and bring out some more of the contrast. Yeah.
Okay. All right, I think I've got it.
It's about 4,000 light years away, and it's an active star-forming region. So that pink region of glowing hydrogen gas, you can see the dust lanes through it. That kind of divide it roughly into three. That's actually what gives it the name, the Triford Nebula, because the first astronomers, when they first saw it, I think it was Charles Messier that first discovered it in 1764. Through his telescope, he saw three lobes, and so hence the name, the Triford Nebula.
Yeah. It's a lovely, it's quite close to what we showed a couple of weeks ago, the Lagoon Nebula as well. So it's nice. You can actually get a shot of those two objects together if you've got such a wide field as well.
Yeah. I think you need something like I think a 200mm lens, actually. So if you've got a telephoto lens and a decent tracking mount, you can get the Trifid Nebula and the Lagoon Nebula in the same frame if you've got a full frame camera.
Yep.
I mean, don't quote me on that, but it's around the 200mm focal range where you can actually get really nice framing of those two nebula in the sky.
And Sinjin was running late. It's okay, Sinjin. We'll finish. We'll forgive you this time. Okay.
Thanks for all the compliments in chat.
Yeah.
This is astrophotography is pretty much my only hobby at the moment.
Yep.
So it's really fun to actually get to show off my images to a wider audience.
If you don't know, Kyle is a doctor.
Currently training to be an MD, so I'm going for that double doctor.
Boy, actually, this is quite amazing. Just the amount of light pollution I didn't realise how badly it would be. But you can actually just see. You can actually see the globe. You can see the pink part of the nebula. Let's have a look. Yeah, and so let's just try and get the little histogram so that it's still.
Was that just 20 seconds, Matt?
Yeah, 20 seconds at 6,400. You think?
Yeah. So.
Yeah.
Unfortunately, with single exposures like this, you're very much at the mercy of ambient conditions. So if there's any smoke haze or clouds, or even light pollution, you're very much at the mercy. And you can definitely see the three lobes that Messier saw, because the little off-jetting of gas that was actually quite prominent in my image, you don't really see with this single exposure. And this gives you a really good idea of what you'd see with the naked eye, actually. But if you're looking through this particular telescope this night, this is very similar to what you'd be able to see with the naked eye.
Yeah. This is why cameras are so good.
Yes.
And
again, the Mark 1 eyeball is terrible.
Yeah. So it is So yeah, it's one of those. It is creating stars. There's actually a nice little open star cluster in between the actual center point of the three dark nebulas you can see here. Actually, three here, and those two stars have actually been adopted by the observatory unofficially, but for our facilities coordinator Ken and also Rob Kennedy, our caretaker, because of all their hard work they'd done around getting the Jubilee Dome up and running, and all the other hard work they've done to keep this place going. So yeah,
they're pretty much up at all hours dealing with problems.
yeah. And if we're coming into moth season now, so if we leave the back door open, for any period of time, we get a whole heap of moths into the main building, and they can set off the alarms. So there was a Saturday where Rob had gone to his farm, Saturday morning, and I got the phone call that I had to go to the observatory at 4 a.m. in the morning after I'd done a night sky tour, and I was.
Oh.
Yeah, that was not fun. So, so it is a very popular target with amateur astronomers. It usually does win. It's one of those ones that it doesn't take a lot to take a nice photo of it, and it does actually win a lot of those astrophotography prizes as well. So. It lies. We're looking at light that's left this nebula about 5,200 years ago. 5,200 years ago. So this is 5,200 light years away from us, and this is about it's about 40 light years across as well. So it is a decent star, and it's only fairly young. It's 300,000 years old. So, that's still. I think humans have been around for that amount of time, haven't they?
About that, I think. Yeah. Like modern humans, pretty close.
Yeah, Neanderthals or.
Yeah.
And the actual it's the open cluster in the center there is called C1759-230. That's This is why you never let astronomers name stuff as well.
Either terrible names or very algorithmic names.
Yeah.
There's not a poet amongst us.
Yeah. And NASA's Spitzer telescope actually may it rest in peace now. I think it's gone to meet its maker. It's they had one of I think it's finally finished this year, but it's an infrared space telescope, and it managed to take a photo of it in January 2005 and revealed 30 embryonic stars, so little baby stars forming, and there are about 120 newly formed stars that had not been seen in the visible light because from the Triford Nebula, just because there was too much dust in the way. That's the good thing about having an infrared telescope, is you don't have to worry about the dust. You just see straight through it because it's looking at the heat as well. Some of the stars found within the Triford Nebula are only a few hundred years old, possibly making the open star cluster one of the youngest open star clusters known as well. So some of them are extremely young, and massive stars that are formed in the region and may have actually ended their lives in supernova explosions because they're so big they don't last long as well. So and what will happen is that those supernova explosions will actually start clearing out that center area and could actually disturb the dark nebulas that make up the Triford Nebula. So I think we'll have to say goodbye for this to this one as well for this year. It's a little sad to see it go because it's so nice and pretty
setting at the moment.
Yeah,
it's a winter object actually. So it's towards the center of our Milky Way galaxy, and in the southern hemisphere, that's best viewed during the winter months, unfortunately. But when you get a cold, clear winter night, that's actually some of the best times to look for objects, because you don't get those nasty inversion layers that cause all the turbulence that blurs your images and makes the stars twinkle a lot.
Yeah, on Monday night, I went to the Natural Bridge up at Kalbarri, and I had like half an hour of just taking shots of the to the west before the full moon came up.
Oh, yeah.
So, but you can see this in the and the Lagoon Nebula in the shots from the Nikon, which was fantastic. And this is located in the close to the lagoon, and using the teapot. It's in Sagittarius as well, so near the teapot asterism as well. So it is. It's definitely a nice one to have a look at during winter as well. And you're seeing baby stars forming. So think of this as a star nursery. All right. Well, what I'll do is we'll show you a one of. We'll show which one do I. Yeah. While I'm moving the telescope hopefully to the Triangulum Galaxy, we'll show them your lovely photo of the Flame Nebula and the Horsehead Nebula, which I'm just putting up right now. So if you want to have a chat about that, and I'll get hopefully get the Triangulum up on the screen.
All right. Well, here you can see it's in black and white. So this is actually one of my works in progress. So I use a monochrome camera to take all my images. So it's not like your standard point and shoot DSLRs where where on the chip there's a color filter. So as you can see, there's quite a bit of detail. And this is using a very special filter called a narrowband filter. So what you're looking at here is light from ionized hydrogen emitted at, I think, 654 nanometers. So again, don't quote me. I mean, I could just look it up on Wikipedia, but and I'm doing this all from memory. And this is what you're looking at here is light from glowing hydrogen gas. So this is interstellar hydrogen that's basically been ionized by starlight. So the biggest stars, with the most powerful radiation, don't actually emit light, primarily invisible light. They emit a lot of ultraviolet radiation, and that's powerful enough to knock electrons off neutral hydrogen in space. And when those electrons eventually find their way back home to the nucleus, they emit light, and it's primarily in the red spectrum, in the red end of the spectrum. You can see here that there's a bright star above the Flame Nebula, off to the on the left side of the frame. That's Ulnatak, one of the stars in Orion's belt. So this is right in the constellation of Orion. You'll definitely need either photographic equipment or quite a large telescope to see these well, because this is all very dim, unfortunately. But it makes for an amazing photographic target. So this is, I think, I had to spend 6 hours just on gathering hydrogen alpha data just to make this one black and white frame. So there's quite a bit of effort going into this, but I think it's worth it. I definitely think it's worth it.
Yeah, it does look fantastic. I think I might have got it. I might have got it. I think it's in the shot. So I'm taking a longer exposure just to make sure I actually have this. So
yeah. So question this is from Mel's. So the horsehead is right in the center of the frame. So it looks like a little seahorse. And off to its left, that's the Flame Nebula. You can see it does look like a fire that's kind of been turned on its side.
Yeah.
Yeah. And those two objects, they're about, I think they're about 1,300 light years away from Earth, and about the same distance as the Great Orion Nebula. So they're all part of the same massive Orion molecular cloud complex, it's called. So very imaginative naming there.
Okay.
And it's a massive collection of dust and gas in space. It's an active star-forming region. It's one of the many ones we have in our Milky Way galaxy.
Good news.
And I think in terms of detail, what I'd eventually want to do with this particular image is get more narrowband data. So I would like to see, get some oxygen emission. I'd like to get some sulfur emission, and make a nice color picture of that. Really bring out the detail.
Did you enter this into the astrophotography workshop? Astrophotography exhibition.
I was hoping to actually get the other two narrowband exposure data first, but I think I might just touch this one up a little bit, just crop the nasty looking edges, and then submit it as is, because I think it's pretty good.
Yeah, it does look amazing. Yeah. Hello KW, how are you going?
Thanks for all the compliments, everyone.
Yeah.
This is really fun. Just being able to take my gear out into the black, spend a bit of time, getting the framing perfect.
Yeah, because
at the end, just mining all this data out. So you would never be able to see this much detail in the Horsehead and Flame Nebula complex without with the naked eye. You need photographic assistance, and I think one thing that Perth Observatory is wanting to do now is do more electronically assisted astronomy. So we get some really sensitive cameras and put them on telescopes and actually display, all right, you can see this with the naked eye, but you can see this in particular, with a camera. Here's how much more detail a camera gets you.
Yeah. You can actually see there's a star right here. I know. Grab it. And this is only just been formed. Yeah, just on the forehead here. And this star has just been formed. And when you have a look, you can actually see that it's blown away the embryonic dust that's covered it. And when it's finally turned on, that's when it's finally come. You can finally see it as well. So you can see so much. You can see all these little cones of where there'd be stars being formed right now if you had a look at it in infrared. So it is it's just a lovely area, and it was one of those ones where when Hubble first took a photo of it, you just realized how good Hubble was going to be.
Yeah. It's like, I think when they first turned Hubble on, it's like, we're not sure how good it will be. Let's turn on some nice bright objects so it looks good anyway. And it was just mind-blowing what they did with it.
Yeah, it was really just a fantastic piece of software for us. Okay, so we're going to settle for 2500, so 25 seconds, and hopefully that we don't get another bit of wind.
Fingers crossed.
Because I did a 30-second exposure just then, and you can see the wind blowing on it. So I think it's some of this light pollution's coming from my screens.
I found a cardboard box that really helps. It's the most low-tech solution available, but just cut a hole in a cardboard box and put it over the screen, and it just works.
Well, actually, I could probably put my jacket. Remember when I was at Astrofest this year? We actually did. I needed. It was still daylight, and I was trying to see on my screen the moon, just so I had it had it focused right, and I just couldn't properly do it. So I just put my jacket. Put my head right up against, right at the screen, and put my jacket over the top of me, and Roger got a nice photo of me. The things that goes.
I remember that.
Yeah. Okay, so there it is, right there. That's the Triangulum Galaxy, and it's a spiral galaxy about 2.73 million light years away from us. So you're seeing light that is left at 2.37 million years ago, and it's quite close to the Andromeda Galaxy as well. So it's the third largest member of the local group of galaxies behind the Andromeda Galaxy and us as well. So it will eventually. I think they're starting to think that it will actually join. It will become part of the Andromeda Milky Way galaxy. That will eventually join in about 4.5 billion years from now.
Yeah, so we got a while to wait for that, I think.
Yeah. So we don't show this object on a night sky tour just because it is so low, but you can see with the camera, we can really you can take some nice shots of it as well, and it's known as the Triangulum Galaxy just because it's located in the northern constellation called Triangulum, as well. So it's got a lot of dust and gas. Hubble actually took a really nice photo of this last year, I think it was. A really high res one, and something like was it 1 billion pixels or something like that?
Something like it was a massive kind of composite image, just a mosaic one, just scanned across it.
It was just a shame they left that little top right bit where they just left the black squares, because we wanted to use it for the for the backing of the wall of the presentation room. So that's all now been done as well. So it is made. There's actually quite a few when we take photos of this, proper photos. You can see there's quite a lot of active star forming areas in the nebula. So it is producing stars, and it's got some really nice dark lanes as well. So it's a galaxy that's roughly around the same age of our galaxy, and it is believed that it is a satellite of galaxy of the Andromeda Galaxy as well. So
I think in galaxy terms it's mid-sized. I think they estimate something like 80 billion stars.
Yeah. And
sorry, 40 billion. It was like double that number. but it's in the grand scheme of things, it's quite a mid-sized galaxy.
Yeah, and they did actually find back in the 2000s. They did actually find that there was a hydrogen bridge or so between Andromeda and the Triangulum Galaxy as well. So it's they have seen that there has been some interactions between the two galaxies as well, and that was confirmed in 2011. So it was discovered 2004 and discovered in 2011, and so they think it's probably undergone a fairly dramatic encounter with Andromeda back about 2.5 billion years ago. So we're talking about half the age of the Earth back then.
Yeah. And it's actually a little bit easier to see in terms of because it's in the north. It's a little bit easier to see than Andromeda because it's at a higher latitude.
Yeah, and it's coming towards us at about 179 kilometers per second as well. Which you would like that that amount that you'd like to go that fast to get to work.
Absolutely.
Yeah, and it's about 60,000 light years. So our galaxy's anywhere between about 100 to 110,000. 100 to 110,000 light years across. So it's slightly more than our galaxy. And if you were to take a nice long exposure in a dark area, in terms of a nightscape photo, it would take up about 2.5 times the size of a full moon in the night sky as well. So it is fairly decent as well. So the galaxy, they think Andromeda has about 1 trillion stars. I'm doing that with
I'm
doing that with the Dr. Evil
in amount of stars.
And also the Milky Way has about 400 billion stars as well. So yeah. And so it's a lovely little little one. We get Andromeda for about 2 weeks of the year, where it goes between the trees and then goes behind the Lowell telescope dome and then into the light pollution of Kalamunda. So it's one of those ones where if it is there, we might just have some binoculars so people can have a look at it as well. What's that orange thing in the middle right? So that will be because so floating leaf. There'll be a star of an orange star just slightly off to the right, and that's what we're seeing. Just an aberration from the camera itself, and yeah. So that's why you get that orange thing that you can see right here. I think that's what you're talking about. Floating leaf. So yeah.
Yeah, that would be due to an aberration due to the telescope optics, maybe internal reflection.
Yeah. So it's you can kind of get these ones when you just got a star just slightly off out of the frame as well, and it was so this one, the Triangulum Galaxy, was actually independently discovered by Charles Messier on the night of August the 25th, 26th, 1764. And William Herschel also compiled it in his extensive list of nebula. He was careful not to include most of the objects included by Messier as well. So, however, this one was an exception, and he catalogued it back on September 11, 1784 as well. So, it would have been amazing to be able to see these objects back then, when there's just absolutely when they were only and trying to figure out what they were as well. So
because the optics and telescopes they had back then, even though they were quite large, they weren't as well figured, or the mirrors and lenses weren't quite as well ground as the more modern telescopes.
Yeah, and it was Edwin Hubble who used this plus the Andromeda Galaxy to find that these were actually beyond our galaxy, and so that they weren't just nebulas. They were galaxies. They were galaxies in their own right as well. So,
I think island universes was quite an early term used to describe them.
Yeah. All right, guys. Well, thank you very much for joining us tonight. I hope you've had a fantastic night looking with us. If you do like what you got to see tonight, please tell your friends and family. And we do these Wednesdays. So the next one of these will be done on the 18th of November. And so please like the video and share it with your friends so that we can help monetize the channel, so we can get some money and we can do better stuff and for this as well. So
yeah,
and also follow us on our Facebook page and Instagram and Twitter. You get to find out the latest news in astronomy, and also they also provide the latest podcasts that are out, and we let you know if there's anything special happening in the night sky, like a conjunction of a couple of planets or the International Space Station flying over quite brightly as well. So thanks very much, guys, and we hope you stuck on